All right, mathletes, here we go. We're going to talk about functions and the notations involved with functions. So, specifically, a function is a relationship in which no two different ordered pairs have the same first number. So, if you kind of think of it in a Venn diagram sense, we can have all the types of relationships or relations between numbers, and a smaller subset of those are specifically called functions. Okay, so a function in math, okay, is a relationship, but it has more restrictions. The restriction is that the ordered pairs cannot have the same first number, meaning what we put into the function, we have to make sure we always get the same output and not two different outputs. So in this example here, we have 5 different dots representing a relationship. The question is this relationship a function? Well, no, it's not. If I look at this point here and this point here, they have the same first numbers there, both being -1 here and here. This is not an example of a function. Okay? So, which of these is a function? So, what we're going to talk about is the vertical line test. So, suppose we draw all possible vertical lines on the graph of a relation. If each line cuts the graph at most once, then the relation is a function. If any line cuts the graph more than once, then the relationship is not a function. So, if I draw a vertical line, and if I draw that vertical line and drag it along my function, if it only ever crosses at most once, so never as I move it, it only crosses the graph once, the blue line representing the function, we can define that as a function. That's making sure that the relationship is a function and it's making sure that we never have an x value that would have two multiple y values. Okay, so if we look over here at B, if I draw a vertical line here and anywhere else, okay, and all it has to do is just fail at one single spot. So here a vertical line crosses twice, more than once, okay, this is not a function. Might be a relationship, which it is. It's a relationship of points that form a circle, but we're going to call this not a function. So the vertical line test with a graph is best used with defining if a relationship is a function. If it ever crosses more than twice or more than once, it's not a function automatically. Okay, so function notation. So learning mathematics is about learning the language and learning notation. So a function can be written in this way. So often a function is given the letter f or any other variable to define that relationship. 2 colons are read as such that an x is our input, and it's converted into 2x minus 1, meaning it's output. Okay? The more simplified ways, the more typical way we should understand this is f of x equals 2x minus 1. That is the most popular way you'll see this written, most familiar way. Okay? Make sure the notation part of this, f of x, this is like naming your function. You can never perform mathematics upon that notation. Don't try and distribute an f times x. That's not what this is saying. Okay? This is the name, okay, of this function, okay, which is equal to 2x minus 1. Okay? Sometimes a graphical representation, how this function is laid out, is it's saying that this is its input. is you input an x into this function. Okay, this function is called f of x. So as you put it through this function, okay, you're going to evaluate some x based upon this rule, double the input, then subtract 1, and you get your output solution here. Okay, this output solution is often what we call our y value. So one relationship that's important to note is that our f of x is equal to y. So make sure I'd have that written down somewhere in your notes. Okay, that you find your y value by plugging in some x value into a function, evaluating it, and it will give you the y value as your output. Okay, so as we go forward here, we're going to look at these functions. So for any function f, the value of the function when x is equal to a is given by f of a, meaning we just substitute in whatever value is in this spot. Okay, so if using the same function as before, if f of x is equal to 2x minus 1, okay, if I want to find f of 2, what this says is I need to let my x be equal to 2. So on my right side I get 2. Well, now x is being equal to 2. That's what I'm substituting in for x minus 1. Okay, well this is equal to 4 minus 1, which is equal to 3. So I can say that f of 2 is equal to 3. Now remember, f of x is equal to y. So I can take this information, and this tells me an ordered pair. The ordered pair is my x is 2, my y is 3. Okay, so I can graph that over here on my graph, 2, 3. Okay, I can graph another point by doing an input as my x being negative 4. So using my rule, okay, says this is saying, notice where the x is here. So if this x is replaced by negative 4, well then you need to replace it on the other side, the x value, with negative 4, just as we did with the 2 before. Okay, and nothing else changes there. So you do 2 times negative 4 is negative 8, minus 1 is equal to negative 9. So f of negative 4 is equal to negative 9. Okay, so my x value is negative 4, my y value is negative 9. I can graph that there. Okay, so if I connect all the dots, I see that my function is an equation of a line. Okay, which is f of x is equal to 2x minus 1. Remember, in previous chapters, we just said graph the line y equals 2x minus 1. And we knew that from our gradient intercept form, that negative 1 was my y-intercept. My slope was 2, so I went up 2 over 1, up 2 over 1. Okay, this is just adding a notational piece of this. Instead of y is equal to 2x minus 1, we're just saying that f of x is equal to y, and we can write it as f of x is equal to 2x minus 1. That's functional notation. Okay, so here in this example, we want f such that x will be inputted as 3x squared minus 4x. Find the value of x. This notation is confusing to me, so I'm going to write it in the notation that's familiar to me, which is f of x is equal to 3x squared minus 4x. Okay, so if on part A, it wants me to evaluate when x is equal to 2. Okay, so I do f of 2 is equal to 3 times 2 squared minus 4 times, well, x appears twice on this side, so I need to, in both places, replace it with 2. Okay, because just like x was here, x was here, x was here, and if 2 is here for f of 2, I got to replace it here and here as well. Okay, so now I can evaluate this, and I do 3. 2 squared is 4. Negative 4 times 2 is negative 8. So 3 times 4 is 12 minus 8, and I get 4. So I can say that f of 2 is 4. That gives rise to the ordered pair 2, 4 on the graph, where this is my x and this is my y. Okay. In B, so if I want to evaluate it at negative 5, so I do f negative 5 is equal to nothing on the right side changes except my x's. So 3, I input negative 5. Always use parentheses here when you're substituting in. That'll help with our negatives. Okay, and then I have negative 4 times negative 5. Okay, and then as I evaluate this, parentheses first, I do 3. Negative 5 squared is 25. It's positive. Negative 4 times negative 5 is going to be plus 20. Okay. 3 times 25 is 75 plus 20. And I get 95. So f of negative 5 is equal to 95. Again, I could write it as an ordered pair. Negative 5, 95. Okay. So another example here. So again, using this notation, but notice now I'm inputting a variable, okay, in a and b here. So don't let it throw you off too much. So f of negative x. So I can do f of negative x. So that means everywhere I see an x on the left side, I'm now going to replace that x on the right side with negative x squared. Okay, so I do 4 minus 3, and I'm going to put in negative x minus parentheses negative x squared. Notice every time I do a substitution, I use parentheses. It's very important to do that, so I remember to be careful with my negative numbers. So now I'm going to deal with my exponent first. Negative x squared. Well, negative x times negative x is just x squared. So I get 4 times negative 3 times negative x minus, now this is just equal to x squared. Okay, and then over here I get negative 3. So this negative has to be distributed here. So negative times a negative is positive. So I get 4 plus 3x, and I get minus x squared. Here, my solution is an expression. I'm not getting a single number answer. So f of negative x is equal to 4 plus 3x minus x squared. Okay? So, same idea, but now, instead of inputting negative x, I'm going to replace everything on the right side with x plus 2. So I get f of x plus 2 equals 4 minus 3 times x plus 2 minus x plus 2 squared. Okay, so first thing I'm going to do is I'm going to deal with squaring x plus 2 squared. Well, x plus 2 squared, I know that I'm going to have to do x plus 2 times x plus 2. Okay, so I get x squared plus 2x plus 2x plus 4, doing my double distribution. And that's minusing this whole term. Okay, so did a little side work there, but I'm going to simplify here. So I get 4, distribute my negative 3 across. So I get minus 3x minus 6, and then it's minus parentheses. I had an x squared. These combined together is plus 4x and a plus 4. Okay. Now, because I'm subtracting away this entire quantity, I'm going to change the signs and distribute that negative, right? It's like a negative 1 out in front. I'm going to distribute it through. So I get 4 minus 3x minus 6 minus x squared minus 4x, changing the sign on that one, and minus 4, changing the sign on those three by distributing this negative 1 to those three terms. Now I just have to collect like terms. Okay, so my constants, I have a 4, a negative 4, and a 6. The 4's cancel out, and I'm left with a minus 6. Okay, now my x terms, I have a minus 3x, a minus 4x, so I'm left with a minus 7x. And I look for my x squared terms, I have 1, just minus x squared. Okay, so I can see that f of x plus 2 is equal to negative 6 minus 7x minus x squared. Okay, so here when we're talking about a domain of the functions, okay, we also need to know that the domain of a function has three issues. There's three things in mathematics that we don't like to do. Okay, one, and I call these our red flags. The first red flag we want to look for is anytime we have a radical. Okay, we cannot take square roots of negative numbers. Okay, so the domain of f of x needs to make sure that this value x has to be greater than 0. Because if I try and do the square root of negative 5, it's undefined. Okay, so my domain, what is my possible x values? Well, my x has to be greater or equal to 0. So I always take whatever argument I have under my radical and set it greater than 0, and that will define my domain. Okay, my second red flag I'm always looking for is anytime I have a rational number or a fraction. Well, I need to remember that I can never divide by 0. So anytime I have a fraction, I grab the denominator and I say that that cannot be equal to 0, and that will restrict my domain. Okay. The other domain issue that I will have is when I'm dealing with dividing by 0. Okay, so a function like this, I got to make sure that this function here cannot be 0. Okay, and so then this has to be greater than 0. Okay, so as I set this up, I know that x minus 1 has to be greater than 0. So if I add 1 to both sides, I show that x has to be greater than 1. Okay, and that's where this comes from over here, because I need to make sure, okay, that I'm not dividing by 0 and I'm not dividing by a negative 1. So let's look at some examples here to finish up. Okay, so the first thing I'm looking at here is I want to make sure that 2 minus x, okay, I know the domain of this function, okay, that this cannot be equal to 0. So I take whatever's in the denominator, 2 minus x, and I say it can't be equal to 0. I simplify this out. So I want to deal with positive x's, so I add x to both sides, add x to both sides. So I say 2 cannot be equal to x. So as I write my domain out, I say a set of x's such that x cannot be equal to 2. And that's my domain. Okay. For part B, again, I have a radical here, and I want to make sure that this part, this x plus 3, okay, it's got to be positive and it can't be 0. So how do you say it's got to be positive and it can't be 0? Well, it's got to be x plus 3 is greater than 0. Okay. Simplify this to get x by itself, so x must be greater than negative 3. So then as I write my domain, I say x such that x is greater than negative 3. Okay, this concludes our notes for tonight. Make sure you highlight any questions you have and bring them to